Good afternoon, everyone. Let's start our chapter 1 for this week's class. So basically, this figure you have known before. I introduced one by one. So roughly, it's about just several very famous examples about artificial intelligence (AI). Okay. So for this chapter, we have the chapter 1 introduction. So we'll first cover these first two parts, two sections in these slides, and then we'll cover the history of AI history in the next slides. Okay, so these slides only cover the first two. So we'll cover two important things. The first one is that AI definitions. What is AI? And then we'll provide you with four different types of definitions, and then we'll say we prefer one than others, and then we need to know why. Okay, and then we'll give you some examples to let you know what's the applications of AI. AI is not new for you, so you have heard this buzzword for a lot. So we'll give you some examples. Okay, just raise your learning interest. Okay. So let's look at the first one. What is AI? If without introducing the knowledge, you may have your own definitions. Okay, and then 100% will give 100 different definitions for AI. Maybe somebody just say AI is just seems like a machine learning, or AI is like robots. Okay, so the reason is also similar like I mentioned for some other things, okay, for operating system. If you are in my class, so even if for general things is not easy to define, for specific ones is easy to define. For example, what is OS? Same for here. What is AI? Also have different definitions. So here we want to provide four different type of definitions. Okay, so here the four definitions is based on two important vectors. First one is whether we look at the thinking behavior, thinking process, or look at the action. Okay, from these two accepts. For example, AI of course is artificial intelligence, means it's not a human intelligence. But sometimes we want to compare the artificial intelligence and the human intelligence. So how to compare? You may just want to simulate our thinking process. Okay? So if you said your AI, you have AI system, and then it's really like a human, it can be called a intelligence, artificial intelligence. That means artificial means it's built by people, okay? Not real intelligence. Even maybe if it's better than human intelligence, but still not real, okay? Not like human. So maybe you can simulate our thinking process. This is first dimension. So that's why you can find that we have two kind of thinking. And the other one is that whether you want to compare the intelligence to a human, compare it to a human or to a general object. So if you want to simulate a human behavior, you can think, okay, the thinking humanly or acting humanly. That means think like a human, act like a human. Okay? But sometimes we don't want to simulate a human. We can simulate a bird. We can simulate a dragonfly. We can simulate a fish. Okay? We can simulate maybe some inanimate objects. That means there's no life, just some physical objects. Simulate a rock, simulate a river, like this. So that means if we only define like humanly, seems like is too restricted. So we want to use rationally. What is rationally? Rationally, you don't need to have a very very concrete definition. You can think about just like do the right thing. That's the rationally. How to measure whether it's right or not? We will have mathematics, we have logic to define. So that's the other thing. That means so based on this analysis, which one you will prefer? Thinking humanly, acting humanly seems too restricted, correct? So we cross these two. And then thinking rationally and acting rationally. So which one is easier to implement or to measure its quality, success degree? Thinking rationally, okay, both are rationally, okay. So we want to measure the results, okay, whether input output, whether it's rationally, correct? Okay, like this one. For example, like a car is driving, okay. So it's driving on the road is rationally, or driving in the river is rationally, correct? Or driving beside the road is rationally, or driving on the road, correct? Just like this. Okay, of course you know what is rationally, but thinking rationally must mimic the thinking process. So only human or some animals can think, correct? Okay, so that means till now we haven't have a very deep understanding about a human's brain. So that means physically we don't know the brain. If you want to know its thinking process, that's even harder. You want to simulate that process for something unknown, correct? Simulate an unknown process, that's also harder for you. So we think this one is not good for us to follow because it's difficult, challenging for us to implement an AI system to have this property, which can simulate a thinking process and also have a good action which act rationally. So we prefer the last one, correct? Acting rationally. So overall idea is that you don't care about its process. You just need to care about its input and output, whether the input output is rationally or not. That's what we want to do, correct? So acting rationally will be the one we preferred. Okay, so here we'll give you some rough idea about just the 4 methods about AI definition. That means you can, based on these 4 methods, of course, based on 2 aspects, 2 features about AI, and then you have 4 combinations, correct? Thinking and acting. This is 2 choices for the first, whether you look at the whiteboard or the blackboard, correct? Black box. The white box, so that means you need to know the detail. For example, the algorithm, you need to test its each branch. You want to do a testing, you need to test each branch, each possible route coverage, correct? You need to have a 100% coverage of all the code and all the possible run-ins, all the possible cases. But that's harder. So that's why usually when we do a test, we'll do black box test first. Black box test also called a functionality test. So as long as it meets our functionality, that's okay. We don't want to say, okay, you must follow something. Okay, you must test completely for all the covered rows. Of course, it's better you have 100% coverage. But if you have enough coverage for this I/O, you also can test, because that's you can use the partition, you can use the border test, different test case design methods, and then you can make it work. Okay. So this one seems like a more feasible one, correct? So people can have a different implementation of AI problem, and they have different AI system, as long as they have the same target, same performance in terms of input output pairs. Okay, So that's great. So that's why, for example, now you know we have a driving car. We have that test. For example, we have the driving car test. We need to do a lot in different metropolitan cities, and also different different rural counties, rural cities, rural areas. Of course, maybe some even in some other scenarios. So that's is similar like this one. In a city, you may meet different situations, and then in different cities, you have different rules and so on, right? And different traffic conditions, different weather conditions. Okay, maybe you need to test in different time as well, different seasons. So that means that's want to cover all the input-output, all the input-output pairs. So that's the idea. Okay, so just remember later we will just mention about, okay, we will explain this one in more detail. But here we will just explain one by one, and then let you know what is the definition for each of them. This one is something like the most important part of this chapter. Okay, just understand what is AI and how to define AI. Let's look at one by one. The first one is thinking humanly. Okay, of course a lot of okay correspond to this one. That's correct. Maybe not correspond to the same order as the book. Thinking humanly. So I mentioned cat. So this one is a very strict one. First one is humanly, only target on human. So must simulate a human behavior. Humans, okay, human. And also thinking, people's thinking process. So it involves a lot of other fields as well. So here is about which fields. For example, we need to know how we do the thinking. So basically this involves, of course, psychology or cognitive science, the first one. Okay, so that means how we make a decision, how we draw a conclusion based on something known, get something unknown. So we have that logic deduction process. So we need to understand this process. But understanding this process involves two things. First one is the thinking process. The second one is because you want to simulate the human brain's thinking process. So maybe you also need to think about how can we simulate the brain in our computer. Okay? So you have a neuroscience. So you need to understand what's the structure of our human brain. Okay, like this one. So this is neurons. So our brain is composed of a lot of neurons. The neurons are connected to each other via something later we'll talk about them. So neural network just simulate our human brain, but it's a lot in this method, thinking humanly. It's like we use acting humanly. Okay, acting humanly or acting rationally, because we simulate our brain, but also can do something else. Maybe not only for human behavior. So you can find here we put some sensors here. We want to understand how our brain works when we look at something. Okay, that's based on the different signal responses. Of course, based on a lot of very detailed devices, maybe based on magnetic, maybe electronic, and so on. So we just want to understand for our different regions of the brain, which region is responding for which type of things. Is it for visual information processing, or for natural language processing, or for our human body's operation, working, and like these things. Okay. So this is hard, okay, because it involves a lot of other things. Even till now, we haven't have a deep understanding about this one. Okay, for example, like this, if we want to do thinking humanly, can we simulate a brain in our PC? Right? This is maybe the first important thing you can imagine. So for example, this is our human brain, and then for our human brain, different parts will be corresponding for different type of functionalities. For example, for vision, for hearing, for natural language processing, for logic deduction, for a lot of things. Anyway, just you have different visions. In fact, people already have some understanding on the human brain, and then we know different regions have different functionalities. Okay, and this is we want to simulate that human brain on a computer, and this one we show the current state of art of our computer functionalities, and this is the human brain. Let's look at, for example, for the human brains, we have this number of neurons, 10 to the power of 11 neurons. If we have a personal computer, it have 10 to the power of 10 transistors. So it's one neuron is like a one transistor. It can simulate a transistor, and then we integrate them together. We can simulate a brain. Like we have a lot of neurons. We have a lot of neurons connected to each other. So we connect this number of transistors. So you can find personal computer seems is only 1/10. So there's a magnitude difference between personal computer and human brain. So we need to have a supercomputer which is good enough. It can simulate this one, because it's more than the required, more than the needed number of transistors. Okay, that's the first one. That means at least we have the basic elements, basic components. So next one, we want to know the storage. So even, for example, even you have this number of amount of neurons, maybe you can store more information based on the connections. So for this one, you can find we have this 10 to the power of 14 synapse. Synapse is just the connection. So that's the synapse, just like this. So that means the neurons will connect with others via the synapse. So synapse, this means how much information we can store in our brain. So it's 10 to the power of 14. Okay, personal computer is 10 to the power of 12. And the supercomputer is 10 to the power of 17 bytes disk. Okay, seems is also okay for us to do that. So it's good fit. So but must use the supercomputer. Supercomputer of course is much more expensive than a personal computer. So if everybody want to have a simulated brain, that's maybe not possible. This is only 1% of this storage. So it's 1%. And then let's look at the speed. So human brain is slower even compared with the personal computer. Okay, even slower, much slower than a supercomputer. Okay, so this is the rough comparison. Okay, rough comparison. This is just like how many operations we can do within 1 second. Okay, not much. Not only 10 more than the human brain. So our brain is still smart enough. So this is quicker, 10 times quicker, but much more expensive for everybody to afford. Okay. So in fact, along this road, people also started some projects. For example, here we provided one project from USA, the other one is from the Europe. Okay. So during the Obama state government time, and then already have this initiative called the Brain Initiative in 2013 April, and then many projects are still ongoing. Just of course, initiative they already allocated some funds for this research. So we want to understand the brain. So it's brain research through advancing innovative neural technologies. Okay. And also Europe also have this similar project called the Human Brain Project. Even we know this is very challenging, but of course, if we want to simulate a real, for example, neural network, maybe it's still better we understand it closely. Even till now, we know the deep learning or deep neural networks has achieved a lot of advancement in some fields, but a lot of older fields, right? So, for example, it is good in visual information processing, but maybe not as accessible as visual information processing in some only just like, for example, decision making system, only just vector data. For example, you have a lot of features like industrial control or some for example in the geography or something. Not if it's a lot info visual information in computer vision and recognition, like pattern recognition, like these things. It's very powerful now, even better than human. Okay, can outperform human's performance. So when we talk about deep learning, we talk about that part. That's why you also can find, I also mentioned last time, right? You find that we have a book, special chapters for that part in this fourth edition. But in the last edition, which is 10 years ago, there's no special chapter for deep learning. Okay. So here has a project called Human Brain Project, develop low-for neuromorphic. What is a neuromorphic? So here I give you and also neuro-robotic technologies based on the brain's security and computing principles. So what is the meaning for neuromorphic and neuro-robotics? So basically you can consider just it's a combination of two things, right? So here we give the link. So the first one, I think I didn't close it. So the neuromorphic. So neuromorphic, also known neuromorphic computing, neuromorphic engineering, is a concept developed by this person describing the use of a very large scale integration, VLSI. That means it's about electronics, right? So that means, for example, now we have GPU that's related to this in hardware production, containing electronic analogous circuits to mimic neurobiological architectures present in the nervous system. So we want to simulate the human's nerve biological system in our chips, right? So this is the basic idea. We use the very large scale integration, VLSI. Okay. So the reason you can find it seems like at least even supercomputer is expensive right now, but in the future maybe it's not that expensive, just like a solid state disk, right? In the past, flash memory was expensive. Now it's cheaper. So we use SSD to replace some part of the disk for storage, hard disk. So we still want to simulate the human brain based on the computer. Okay. So the second one is neuro-robotics. So this is the combination of the three things: neuroscience, robotics, and artificial intelligence. So basically it's these two parts, neuroscience and robotics. So it's the science and technology of embodied autonomous neutral systems. Okay, it's about these things. So basic idea, I give this example, just want to let you know. So along this dimension, we are also doing some research, still doing. So you can find that only one breakthrough we have caused a lot of new products in our in our society, in our world. Okay? So the research, in fact, you need, why we said research and development. So you need, if you maybe not have enough information about what's the relationship between research and development, R and D. Okay? You need in the universities and institutes, research centers, they focus on foundation research because that will cause more important breakthroughs. Okay, some innovative things. And then for companies like this private sectors, they will do more towards the development, but they also need to do something new. Sometimes it's like they complement each other, right? And the industry has the money, they can invest in some research and then collaborate with research universities and centers, institutes, and like these things. And then this will cause tremendous breakthroughs, not just like a bit by bit, right? And also, in fact, companies also have some research departments, just like for example Microsoft, they have some, in China there's a Microsoft research center in Asia, okay? Microsoft Asia, okay? So that means a research center. That's like a focus on research. And also they have engineering in China as well, in Peking, I think. That means both science and development, scientific research and product development, they integrate together. So it's like the customer for the scientific research is the engineering center, right? So they collaborate each other. So the reason is that we want to bring some new things. For example, like in the around 2012 or 13, the Kinect, right? So initially we want to use the Xbox for game, but later we found Kinect is good for us to do some research. So they develop some APIs for the researchers as well, and then it's become a very popular tool for people for human action tracking, right? They can track 26 joints of our human body, so track our movement. So besides gaming, they can also provide some tools for research and so on. In fact, that's also due to the research, right? They have this tool. So they can track the human body's movement, but also can receive voice commands as well. Okay. So this is the first. Okay. So let's look at the second one, the AI definition 2. So we said thinking humanly seems challenging, at least in the current stage. And then we want to look at the second one, acting humanly. Okay, acting humanly. So this person is a famous cat we mentioned to you. So it's Turing. Okay, Turing Award is the most important award in computer science. Okay, it's the Nobel Award in computer science. So in fact, Turing has published a very famous paper called Computing Machinery and Intelligence. Okay, it create a famous test, Turing test, correct? What happened? It seems this is not what I want to have. Okay. So the Turing test, you can find the paper there maybe. The Turing test is doing like this. Okay. So why we want to have Turing test? Because you claim your computer system has human intelligence. Okay, I just put your computer system or AI system side by side with a human. Okay, of course your AI system must have a similar abilities as a human. You can listen to me, correct? Or you can read, and then you can understand the question. You can do logic deduction, and also you can just do some other things. I think we have storage. You need to have some storage, correct? You need to have some storage there, and also you can learn from examples. So this is how we required AI system has in the Turing test. That's the full requirement. Natural language processing, you may just read. If I prefer that you just only read. Okay, for example, I send a question to a human can read, and then AI system also can read a document. That seems not hard. And second one is knowledge representation. People can answer some questions just because people has the ability, okay, has the knowledge. For example, we want to know, okay, whether Canada is on the lost part, in the lost of USA, or on the south of USA. So we have some knowledge, correct? What is south, what is lost, and then we have the geographic knowledge. So we need to store the knowledge in our brain, and then you can do that thing, correct? You can do. Sometimes maybe we are not just based on this direct knowledge. We need to use the knowledge and then do a deduction. Okay, and then that's called automated reasoning. So human our brain, so we can reasoning. We can do something. We can work on questions, okay? We can work on problems. We can do a reasoning. That's why we are starting here. Okay? We can understand something. We can create something, learn and then create, and then do some work. And then machine learning. Machine learning basically that means sometime I will teach you one by one. You know something, but you also want to do something by yourself. For example, I teach you addition. Is 1 plus 1 is equal to 2. 1 plus 1 is equal to 3. And then again and again, I teach you some examples, and then you need to understand. Based on these examples, you learn, do something unknown. So learn from examples. So that's a typical statistic machine learning. So we require the AI system has these 4 capabilities. So what is the Turing test? In a word, is that I will prepare a set of questions. So I'm the human interrogator. Interrogator. Just like I will be the judge. I will provide some questions, and then I will give the question to both the human and the AI system. If the answer cannot be discriminated by me, so the AI system passed that question. If you pass all the questions, AI system pass all the questions, we can say AI system has the human intelligence. So this is how we said. That means that the AI system passes the Turing test. So we said, okay, this is successful AI system, at least defined in the context of those questions. So of course you will have a question. So how can we design the questions? The first one, to make it equal, this question set. Okay, this question set is equal to intelligence. Okay, this is question set. You have a lot of questions, so they are equal. Once you passed questions, all the questions means the AI has the human. We can say it's the intelligent AI system. Okay. The first one, how to do this. Second one, even you find a lot of questions, how can you make sure this is equal? Correct? How can you prove, okay, this number of questions? Because even I tell you, for example, you know how to do addition. Okay, you can do. I give you a lot of addition questions to you, to both human and AI system, both can do that. But I can do 1,000 examples. Okay, maybe 1 million. Yes, but there's an infinite number of additions. How can how can you list all the questions, make them answered by each of them? Okay, you cannot test it because it's an infinite number of additions. Okay, you have integer, you have float, you have double, okay? You have mixed, and maybe sometimes it's overflow cases and so on. So a lot of cases. Okay, so that means, of course, here we want to say you need something is like when we don't have some solutions, you need one solution is better than no solution. Correct? At least this gives us just like a test. For example, now we have a COVID-19. We use the test. So if we test is positive, we still cannot guarantee it's 100% accurate. But at least it has maybe 56 accuracy. Correct? That's why. So, but if it's 3 times, we can test more times. Correct? If 3 times are negatives, so we can say maybe the confidence level is very high. So that's the reason. That means the Turing test cannot answer all the questions, but it can answer partially. At least it can filter out some AI system which is not intelligent. Correct? Because even we have this minimum requirement, this AI system cannot pass. Then we can say this is not has not reached the standard. Okay, so this is the thing. Okay, and the Turing just designed this test in published this paper, and then he predicted by the year 2000 machines would be able to fool 30% of human judges for 5 minutes. Okay, so in fact for this one, I think till now still hasn't reached goal. So sometimes usually we can say just the progress will be slower than you expected for the optimistic persons, the prediction, but quicker than the person who don't believe it. So just like, for example, currently AI just suddenly, you can think it's suddenly, but in fact even AI goes with several winters, twice winters, correct? And then till now, during that winters, people still doing research, and then they still break through. So little by little. When all the things are there, we said the data, correct? Big data, computational power, and efficient training algorithms, and also of course good models. All of these things are there. So still algorithms, correct? So data, computational power, and algorithms. So input and algorithms, and also the hardware to perform the algorithms running. All of these things are prepared. Then you will have a very steep increase in the performance and also in its progress. Okay. So here we just mentioned about the Turing test. Maybe it's too optimistic, but in fact, we also want to mention about it some limitations. Okay? We mentioned about some. For example, here we talk about the first one. Some human behavior is not intelligent. For example, you have some reflective behavior which is not intelligent. For example, if you have some for example, we put our hands on over a burning stove, and then you will move your hand quickly, right? Because this one will prevent us from burning. So this one is not controlled by our human brain. Okay, we human brain, whether we put this 1 second is good enough, or 1 millisecond or something. In fact, our brain didn't control this one. It's reflective. Okay, it's reflective behavior. So how can you simulate that reflective behavior? Because it doesn't relate to intelligence. Okay? So how can you measure intelligence degree of this behavior? Because it's not intelligent, it's just reflective. So that means that test has some limitations in testing this type of behavior. Okay, the first one. And the second one, some intelligence behavior may not be human. We said, okay. So because that one is just doing the, for example, compare the answers with the answers of human, right? Answers of machine and the answers of human. But sometimes we want to simulate some other things. Okay, they are intelligent but not human. Okay, it's not a human's behavior. Okay, for example, we do flying. Okay, we do some other animals or some other objects. This is also a limitation. That means because that test is designed just thinking, is just like acting humanly, is humanly, right? So not acting rationally. So that's why we only compare with the human. That means this one is only workable for human AI system. That means stimulate human behavior. But if it's not human behavior, I said, like a dragonfly, like a butterfly, like a fish, right? We have some robot fish, and then we can use it to test the flow, test the pressure of water, right? A lot of water areas and so on. And then human observers may be easy to fool. Okay, so the observer here is just the judge, right? Human interrogator. So the human interrogator may be fooled by the AI system. So here we give several examples here. For example, we have the chatbots. Okay, chatbots. So we click this one and then see it. The reason is that a lot of this one depends on the expectations. Let's stop a little bit. We finish this one first. So that means a lot of depends on the expectations. That means expectation. That means we only care about the output. Sometimes even we don't understand the question, but we can just try the error. Okay? Later we talk about we have a Chinese room question, which is also like this. So that means it cannot just answer the 100% in terms of the question, whether after testing and Turing test, whether the system really understands the question. Is it like just want to learn to map between input and output, or just really understand the question, okay, and the answer? So you don't know the logic process. Okay, so this is the most important thing. So we call this is anthropomorphic fallacy. This is maybe some word you didn't use a lot. So this is basically like just you simulate a human, and then even the behavior is like a human, but in fact the internal thinking process or logic deduction process is wrong. Okay? Because you just want to get an answer. Just like you doing exam. Even you multiple choice questions, you may misunderstand the question, but just because this misunderstanding, your answer is correct. Correct? So negative plus negative is positive. Correct? Negative multiplied by negative. So like these things. So let's look at one example called a chatbot for this one. Okay, I think maybe you cannot hear cat.